Hello, I would like to go here over the entrance exam Maths B of July 23rd, 22. Idea is that I will go over all the 22 exams, and as it comes out also of the recent April 2023 exam. Okay, question 1. A rational function and a family of parabola. So we have this function, this quotient here, and then a family of functions with a parameter a, and indeed they all describe parabolas. Now compute the coordinates of the intersection of f and this graph of g5. Okay, so we just have to set them equal. We need to set f of g equal to g5 of x and see at what point x that will happen. So that means that 8 divided by x squared has to be equal to 5 minus 1/2 x squared. And now, assuming x is not equal to 0, which is not going to be a solution anyway, we can multiply both sides by x squared, so we get 8 equals 5 x squared minus 1/2 x to the power 4, which I will rewrite as 1/2 x to the power 4 minus 5 x squared plus 8 is 0. Now with this, one part in the materials is that you solve these things by substitution. We can just say, define, let's say, y as x squared, and then this becomes 1/2 y squared minus 5y minus 8 is 0. I multiply by 2 to get a coefficient in front of y squared to be 1. So I'll get y squared minus 10 minus 16 is 0. So let's see, this is wait, this was a plus. This was a plus. All right. Start. And that's actually nice, since now I can factorize it. I recognize that minus 2 times minus 8 is 16, and subtract these or add these, then you get minus 10. So you get y minus 2, I'm sorry, y minus 8 is 0, which means that y is either 2 or y is 8. And now go back to our original definition of y in terms of x. So we find that x should be plus or minus the square root of 2, or x is plus or minus square root of 4, of 8, which is plus or minus the square root of, we just write 8 as, you just do prime factorization to simplify this, as 2 times the square root of 2. So these should be our solutions. Is there anything about domains or stuff? Also check that x is not equal to 0. So let's compare the solutions. Have them open here. Okay. Yeah, one thing, I should actually do the coordinates, so I should also evaluate y by substituting in this equation. Oh, well, I might have a point subtracted in that case. Question 1b. For each p greater than 0, there's a vertical line LP with equation x equal p, and that intersects f in the point fp and g in point gp. And well, gp actually in the graph of the function g1 of x, which is 1 minus 1 half x squared. Then they ask compute the value of p for which the distance between fp and gp is minimal. So we can look, so we look at a vertical line with p greater than 0, so it can be anywhere there. Yeah, you kind of see that here the distance between f and g will be large, then get smaller, smaller, and probably around here it will be smallest and increase here. So what do we need to do? Well, there is a note in the materials about the vertical distance between two graphs, and that's the absolute value of the difference of the two functions. Now, since it's an absolute value, you actually need to know, it's something like absolute value of these functions. You need to know what the sign is. But, well, let's have a look. This a is 1. G2 here, this is a is 2. So with a equal to 1, this function g will be even lower, so it's probably reasonable to assume that f is always larger than g, and that you can just evaluate f minus g. But it's still something we better check. Actually, let's check that. Let's again set these two functions equal. 8 divided by x squared. In this case, what was a? Is 1 minus 1 half x squared, and do the same thing as we did above. Get this, x squared minus x to the power 4. So you get plus 1 half x to the power 4 minus x squared plus 8 is 0. And that means that plus, of course. at x to the power 4 minus 2x squared 16 is 0. And can again substitute the y like this, so we'll get y squared minus 2y plus 16 is 0. Did I do it right? X squared. Okay, looks good. And now let's look at the discriminant. We want to figure out whether or not this equation is a solution. And if f is always larger than g, there's actually no solution. So it's b squared minus 4ac with these coefficients. So that's actually 4 minus 4 times 1 times 16. Yeah, so this is smaller than 0. So this equation has no solutions, and you can just substitute an arbitrary value, say x equal to 1, and then you find that f is actually greater than g. Okay, I'm not 100% sure if this is required to get the points for this. But anyway, so this is the distance, and now we need to find where it's minimal. So we need to find the extreme of f minus g. So we need to take the derivative. So we need to set d dx of 8 divided by x squared minus 1 minus 1/2 x squared is 0. So we get this is x to the power minus 2, so you get minus 16 x to the power minus 3. The derivative of 1 is 0, and you get 1/2 x squared, which has a derivative of x. So you get, with a sign here, you get a plus x. So it means this is 0. What can we do? We assuming x is greater than 0, which is definitely has to be the case, we can just multiply it by, say, both sides by x to the power 3, for example. So I get minus 16 plus x to the power 4 is 0. Or this means x to the power 4 is 16. Which means x is plus or minus 2. And then we should exclude 2, and that means we only find x equal to 2. So that means p is equal to 2. And solving something like x to the power 416 is something mentioned also in the materials in other power equations, that x to the power n is a, means that x is plus or minus the nth cube root of a, which in this case is the fourth root of 16, plus or minus, which is plus or minus 2. Question 3c. In the figure below we have another function g2, so a is 2, and you can define a point C which is the intersection of g2 with the positive x-axis, and there phi is a region here enclosed by g2 and the horizontal line y equal 2 and the vertical line through C. So try to visualize all that. W is the region enclosed by F, and the vertical line through C, the x-axis here on the bottom, and the line LP with equation x equal to P, with P larger than the x component here of C. So that is here. There is a value of P for which the area phi is precisely half of the area of W. Okay, find this P. Okay, well, let's just find the area phi, write an expression for it, write down an expression for W, and then just set this requirement here. So for phi, and so we need to use the equation for the area between two functions, and that's somewhere in the materials. It's just the integral of the difference between the two functions. So here the top boundary is y equal to 2, and the lower boundary is the function g2. Well, we have to find the x-coordinate of point C, which is defined here. So we set g2 equal to 0, which gives us, so what's xc? That's the first thing we want to do. Well, we set 2 minus 1/2 x squared equals to 0. Okay, so simplify this a little bit. Minus x squared multiplied by, multiplied by minus 2. It's going to be pretty simple. You get x squared minus 4 is equal to 0. Which means that x is plus or minus 2, but we should rule out negative 2. This function is anyway symmetric here in the y-axis. So we rule out x is negative 2. So xc can only be 2. And why do we rule it out? Because it has to be the positive x-axis. Okay, so I think we 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 might just double check that when x equal to 0 that it's indeed y equal to 2. So we can start the integration here by 0. Probably you should still write it down. So we found xc and we want to find the start of the integration. That's found from g2x. We want to intersect with this line y equals to 2. And but that's trivially this equal to 2. You drop 2 on both sides, so it only has the solution x equal to 0. Okay, so now we can calculate phi. So it's the integral from 0 to 2 of the upper bound function, which is this 2, and minus our function minus 1/2 x squared dx. So it's nice that these 2's drop here. So it's just 0 to 2 of 1/2 x squared dx. And that's so we would calculate the primitive. We know it has to be x to the power 3, and we need to compensate for this factor 3 we're getting here. So it's 1/6. So if we, again, always double check, take the primitive of the derivative of this, and you should get the function back, which is the case. So between 2 and 0, that's then 1/6 times 8. It's 8/6, which is 4/3. And this phi doesn't depend on p at all, obviously, but w will. And so where does the integral for w start? Well, at xc, so at 2, and that goes all the way to p. And the function, the upper bound function, is the function f, which is 8/x squared dx. And we need to subtract basically the line y equals to 0, the x-axis. Which I didn't explicitly write down. Okay, so what's that? What's the primitive of x to the power minus 2? Well, we make it x to the power minus 1. If I take the derivative, I get an x to the power minus 2. But I want to get x in 8 and not a negative sign, so I'll compensate it by multiplying this by minus 1, get minus 8 between p and 2. Again, double check this. So it is a minus, so I evaluate it at p, then subtract this at 2. So at p I get 8 over p and minus that thing evaluated at 2, which is minus 8 times 2 to the power minus 1. So it's minus 8 over 2. So let's just get rid of the parentheses first. It's minus 8 over p plus 4. Okay. And you can kind of see it makes sense. Let's say I substitute p equal to 2. Then this integral becomes 0, and that's the case when you basically upper bound is the lower bound, so the integral is 0. And now we need to set, basically we need to say that w is twice v. So that leads us to the equation minus 8 over p plus 4 is equal to 2 times 4 over 3. Simplify it a little bit. Minus 8 over p is 8 over 3 minus 4, and this is 12 over 3. So 8 minus 12 is minus 4, is minus 4 over 3. Then I can get rid of the negative sign. I just do the cross product. So I get the cross product. You have two quotients here, and p cannot be 0. So I get minus 24 equals minus 4p. And means p is equal to, in the end, equal to 6. It's best when you do this, just to go over it again to be sure no mistakes are made. I have the answer sheet somewhere. But answer here is correct. Question 2a, we have this function f, and it has 1 point of inflection. It's already given. Compute exactly the coordinates of that point. So point of inflection means, well, this whiteboard is pretty terrible. It means that, what I say, so the second derivative of this function has to be 0. So we can use the quotient rule of differentiation, namely that the derivative of f over g is g times the derivative of f minus the derivative of g times f divided by g squared. So what do we get here? We get e to the power x plus 2 times the derivative of the numerator, which is just e to the power x. The derivative of e to the power x is e to the power x. Then minus the derivative of the denominator, which is this ex plus 2 times the function no. G I need to take the derivative of the denominator, which is just e to the power x. Times the numerator, and this whole thing divided by power x plus 2 squared. So how can we simplify this? Obviously there's a common factor. This e to the power x times e to the power x actually drops against this. So it's just 2 times e to the power x divided by e power x plus 2 squared. So that's our f prime of x. And our f double prime of x will then be derivative of this thing, and we follow the same rule. We get e to the power x plus 2 squared times 2 e to the power x, since that's just the derivative of f, and minus the derivative of the denominator, which is 2 times e to the power x plus 2 times the derivative of the inner function. So I applied the chain rule, so I have to take the derivative of g squared. That's e to the power x, and then times my f, which is 2 e to the power x. Okay, it's a little bit messy. Best to double check this. So this is my denominator times the derivative of the numerator, and minus the derivative of the denominator times the numerator. So this is all correct. I can actually drop this and drop this. Oh, this is actually power 4. So this becomes 3. So I get e to the power x plus 2. I put the 2 in front, and e to the power x minus 2. Minus 2 times 2 is 4. E to the power 2x divided by e to the power x plus 2 cubed. Okay, if we can simplify this a little bit more, this is equal to 2 e to the power 2x, since e to the power x times e to the power x is e to the power 2x. And the second term is 2 times e to the power x, so it's plus 4 e to the power x and minus 4 e to the power 2x. Again, times this cube term. Then I just get 4 to the power e. These two I can combine, so minus 2 e to the power 2x, step by step. And this is, I can now factorize a 2 times e to the power x. It's kind of the common factor in both terms. I get a 2 and then a minus e to the power x. And this has to be 0. So f double prime 0. And you can just say, because this is e to the power x plus 2, which is always positive. This means that this denominator here has to be 0, and e to the power x term here cannot be 0. So it just means that e to the power x has to be 2, which is equivalent to x being the logarithm of 2. Now, since you would still need to check that this is a extreme to show that it's an inflection point, but since they already tell you it has a point, we actually don't need to do it, since it's a given. But otherwise you would need to check that that this is actually an extreme of the derivative, so that the derivative changes sign at the point of inflection. Goes from negative to positive or positive to negative. But we don't need to do that here. And let's see if that makes sense. Actually, yes, but I was again a little bit sloppy. I didn't calculate the y value here. So I'm not sure how much will be subtracted then. But obviously that's pretty easy to find. Either substitute e to the power x in the equation. E to the power x is 2 in the equation here, so y is just 2 divided by 2 plus 2 is 1/2. So the final answer then is log 2, no, 1/2. Log 2, 1/2. Question 2b. We have this graph G and region V enclosed by the x-axis, the y-axis, and the graph of G. Okay. Compute exactly the volume of the solid of the revolution that's formed by rotating phi around the x-axis. Okay, so this is treated also in the materials as something you need to know. I won't go through it, but what do we need to know? We need to know, well, the left border is just x equal to 0. But what about here? This is the intersection of this function with the x-axis. So we first need to find out what is the right point of the integral. Okay, so we set gx is 0, which means e to the power x times e to the power x minus 4 is 0. Okay, not too difficult. That means e to the power x is 4. And from some of the basic rules also in the materials, that means that x is a log of 4. Terrible lag. Okay. So, well, then it's not too bad. So we need to get the rotating volume. Let's call that R phi. Would then be the integral from 0 to log of 4 there have to be pi in front. Just remember the area of a circle is pi r squared, and integrating that will give the rotating volume. So, and the r squared is basically the function here squared. Well, what is gx squared? I just square these individual terms. So I get e to the power 2x times e to the power x minus 4 squared. Dx. Okay. Well, let's just expand these parentheses here, so you get all individual terms, individual exponential functions that you can find the primitives of. So you get pi times the integral e to the power 2x times e to the power 2x minus 8 e to the power x plus 16 dx. Again, make no mistakes here, because you will pay for it. Not only you lose score, but you get likely more complicated expressions that will hurt you later. So I already made the mistake, did I? No, so this is fine. So pi times the integral e to the power 4x and minus 8 e to the power 3x, and then finally plus 16 times e to the power 2x. dx. And this is then pi and finding primitives of this is pretty straightforward. You use kind of a reverse chain rule. You just need to take into account that you get an extra factor when you would differentiate this. So you get e to the power 5x actually 1 over 5 then. E to the power 5x, take the no, what do I do? Oops. I get 1 over 4 and e to the power 4x. Microsoft Whiteboard is terrible, but I haven't found something better. So 1 over 4 times e to the power 4x. So if I take the derivative of this, I get the function itself, e to the power 4x, times the derivative of the inner function, which is 4. So I get this back. And here, similarly, I get 1 over 3 e to the power 3x. And then 8 times e to the power 2x. This I have to evaluate between what was the between log 4 and 0. Okay, why not? So I get pi, then evaluate that whole thing at log 4, so I get e to the power 4 log 4, but that's just well, you can for example write it as e to the power log 4 power 4, which is just 4 to the power 4. Oh, I get 1/4 times 4 to the power 4. Well, let me just still keep it like this. And the same way I get three to the power no, 4 to the power 3 here. I substitute log 4. And here I would just get 8 times 4 squared. And then this whole thing calculate at 0. Oh, it's 1/4 minus 8 over 3 plus 8. Okay, it is what it is. Including the lag on Microsoft Whiteboard. Okay, I get here, this is 4 to the power 3, which is 64. And this is 64 times 8 divided by 3. Well, okay, why don't we use a calculator? 64 times 8 divided by 3. Oh, 512 divided by 3. And this is 16 times 8 is 128. And this we can, I guess we all need to put it under minus 1/4 plus 8 over 3 minus 8. This is 64 plus 128 minus 8. Is 184. And let's just just put it under a common denominator of 3. So plus minus 512 no. Yeah, let's just evaluate these. Minus 512 plus 8 over 3. Minus 1/4. Then you get minus 504. So let's actually do the prime factorization. 252. 126. 64. Ah, so this is 2 to the power 6. 2 to the power, of course this is 2 to the, this is 2 to the power Okay, so now we need to work this out. Let's get rid of what do I get here? I have 4 to the power 4 divided by 4, which is 4 to the power 3, which is 64. And then minus 4 to the power 3 is 64 times 8 divided by 3. So I've got 8 times 64 divided by 3. That's not a whole number. Well, 8 times 64. Yeah, of course, this is 5. This is just, yeah, basically, this is 2 to the power 6 times 2 to the power 3, so 2 to the power 9, which is 512. Okay. Oh, the lag is really terrible. Sorry, I have to write really slow. And here I get a plus 8 times 16 is 80 plus 48 is 128. And minus a lousy quarter plus 8 over 3, and then another minus 8. Okay, let's just sum these whole numbers here. So 64 plus 128 minus 8. Is pi times 184. I can either put this on a common denominator of 12, or let me first evaluate these two. So minus 512 plus 8 is 504. And that's divisible by 3 actually. 5 plus 4 is 9, since the sum of the digits is divisible by 3. So this is 168. So I combine these two, but I still have my quarter here. So this is pi 184 minus 168. Let's see, 16. That's 16 minus 1/4 is pi, and this is 15 and 3/4. Well, what are the chances? In your exam, you have to just step by step still do it just one more time. Although, yeah, this is correct. To C, there's this function h. Compute exactly the coordinates of the intersection points of the graph of h and the line with the equation y equals log 8. Okay, we need to solve the equation log x plus 2 log x to the power 3 is log 8. Okay, so let's combine these. Let's use some of the properties of logarithms that we know. First, get rid of this factor and bring this in, and then we can add these logarithms. So we get log x plus 2 and log x to the power 3 to the power 1/3. This we know. This basically is a log of x. This has to be equal to log 8. So then you can have the sum of two logarithms. That's the logarithm of the product of these, the arguments. So this means log x plus is log 8. And so this is the log taken overall. That's also equivalent. It's also part of in the materials to saying that this thing inside, so x squared plus 2x is 8, which is equivalent to x squared plus 2x minus 8 is 0. Which hopefully you can factorize 2 and 4. Minus 2 and plus 4, yeah. Plus 4, 0. So that means x is equal to 2 or x equal to minus 4. Now, this is one check you need to make. is that the argument of the logarithm has to be positive, and let me see, which means we should rule out -4 here. You get a logarithm of -2 and another negative number, but x equal to 2 is fine. You just substitute it and you find that it's okay. Alright, so I shouldn't make the same mistake of not also writing the y-coordinate, although it's trivially log 8. So anyway, still write down the full coordinates, 2 and log 8. Okay. Next question. For each real value of p, the function kp is given by this. Compute exactly the value of p for which the tangent line to the graph of kp in the origin passes through point A, which is 1, 2. Exactly the value of which the so this tangent line, well, I actually have no idea how this function looks like. But at 0 it is log 1. At 0 it is indeed, this function is 0 for actually for every p. Goes to 0, and well, actually we don't know the sign of p, so actually I don't know how it looks like, but it's not really important. Just the point of this question is, okay, let's say that the function looks something like this. Then in point 0 it has a tangent line here, and this tangent line has to go through the point 1, 2. Okay, 1, 2. So it goes through 0, 0 and 1, 2. So what does that mean? Well, that means that the slope of the tangent has to be the slope of the line going through the origin and 1, 2. So the slope has to be 2 minus 0, well, divided by 1 minus 0. So this is a 2 here. That line will go through the origin and 1, 2. So the slope has to be 2. In other words, the derivative of this function has to be, let's write this. Okay, I'm going to stop using Microsoft Whiteboard since the lag is just not tolerable. I'll do it in the next question. So the k prime of this function for a certain p at 0 has to be 2. Okay. Okay, what is the derivative of a logarithm? Or what's the derivative of this function? Well, k p prime of x is 1 over, remember the standard function logarithms, 1 over that function px squared minus px plus 1, and using the chain rule I get 2px minus p. And evaluated at 0, I get just that's all correct. I get just negative p. So in other words, our p has to be a negative 2. Question 3. In the figure below, the graph is shown of this function here, a sum of a cosine and a sine, with a different period, as you can see. Actually, the period can be found from the coefficient in front of x. That's some of the known materials that you need to be aware of. The period is 2 pi over that, say, coefficient c in front of x. So c is 1 for the cosine, which gives a period of 2 pi, and c is 2 for the sine, so the period of the sine is 2 pi. And then, since it's a sum of these two, the period of this sum function is the least common multiple of these two periods, which is 2 pi. So the period of this function should be 2 pi. Anyway, that's not even what is asked. I think I saw this mentioned somewhere under parametric equations, so it might be good to know this. But what are they actually asking? They say that the derivative function can be written as this, and we need to show that. Okay, so the approach will be to take the derivative of this function, and that is pretty straightforward. The derivative of a cosine is a minus sine. We get minus 2 sine of x, then plus, using the chain rule here, we'll get the cosine of the inner function, which is 2x minus 1 over 6 pi, then times the derivative of the inner function, which is 2. So let me just rewrite it a little bit. And they already give the answer, so we kind of we have to somehow show that this is equal. And for this, you can use a symmetry property of the sine and cosine that is given in the materials. Basically, the sine of x is a translated cosine. It's cosine of x minus 1/2 pi. So if you draw a cosine and so the sine will be like this. Anyway, this is a little bit messed up, but terrible at this, but you can see that you need to translate the cosine function to the right by 1/2 pi. So this is the sine, and here the cosine. If I translate it to the right, I get sine back. So, and as there are several of these symmetry properties that it's best to be aware of. Okay, so then we apply this. We apply this here. So we have a cosine 2x minus 1/6 pi yeah, so let's rewrite this a little bit, and since this is equivalent, saying that sine of x plus 1/2 pi is the cosine of x, you can reversely say that the cosine function is the sine function translated to the left. Okay, so this will be then the sine of whatever is here, 2x minus 1/6 pi plus 1/2 pi, and that is, so we need to know what is minus 1/6 plus 1/2. That is minus 1 plus 3 divided by 6. It's 2/6, which is 1/3. So get the sine of 2x plus 1/3 pi, which is actually what you see right here. So just to complete the question, we found that don't forget the 2 here. It's 2x plus 1/3 pi. So question 3b, we need to compute the x coordinates of the points in this interval at which the tangent line to this graph is horizontal. So from minus 2 pi to 2 pi. Okay, so there will be quite a few points where that happens. Well, we just the derivative is already given, so the approach will be to solve for the derivative being 0. So we get minus 2 sine of x plus 2 sine 2x plus 1/3 pi has to be 0. Now this equation is of a form that is actually I mentioned this in some introduction video, but what does it mean if let's say we can divide out the 2's here, and we can say the sine of x has to be equal to the sine of 2x plus 1/3 pi, and it would be easy to say that that means x is 2x plus 1/3 pi, but that will be wrong. And the reason is due to the periodic behavior of these signs. So yeah, one thing is say you look at a unit circle, and I want to set the sign equal to a certain y value. Then you see there are generally two solutions, and say this is a certain a, then if this happens for x, it actually also happens for, well, what's this? Pi minus x. And this is one other symmetry relation you need to be aware of, that the sine of x is equal to the sine of pi minus x. So yeah, if x is equal to this, certainly this is true, but if x is equal to pi minus this, it's also true. So you get many more solutions. And then obviously if this is a solution, then I can also add 2 pi to it. I can rotate by 2 pi, it's a solution, and the same for the other solution here. And you can add 4 pi, 6 pi, or you can subtract 2 pi, etc., etc. Anyway, that's something you have to be aware of. I've seen these kinds of things quite a few times. It's probably best to memorize it both for the sines and the cosines. Let me write. So for the sines, we have, say, if the sine of x is equal to, say, the sine of a, then we have sine the x is equal to a plus 2k pi, or x is pi minus a plus 2k pi. And if it's cosines, it's actually a little bit more easy. If it's cosines, if cosine of x is equal to the cosine of a, then x is just plus or minus a plus 2k pi. I definitely advise remembering this. So let's apply this. And basically substitute a for this term here. You get x is 2x plus 1 over 3 pi, or no, I forgot the other solutions, or x is equal to pi minus that thing here, two x plus 1/3 pi, and then I also can add 2k pi to it. Doesn't matter if you put it inside with the minus sign here, actually, since k can be any positive or negative integer. So now I bring x to the left, and I get a minus x, so I multiply this thing by minus 1, then I get x is minus 1/3 over pi plus 2k pi. But here, let me write this out. You do the same, you bring this term to the left, and you get 3x. So it becomes the second one becomes a little bit messy. So I get, sorry, what did I do here? This is a plus. So I get a 4 over 3 pi here. Uh, 3x. No. Okay. Step back. Let me actually fix it here. I bring my x to the left, I get 3x, and then I just do pi minus 1/3 pi. And now I need to divide both sides by 3. So I get 2 over 9 pi. But then all these additional terms will have a 2/3 k in front. So it's 2 over 3k times pi. Okay, now we just need to enumerate within this interval what the solutions are. So let's start with the one on the left. This starts with, systematically go over the different values of k. So start with 0, then you try 1, 2, until you're out of the interval, and then after that you go to -1, -2, etc. Hopefully not too many are required. Okay, so k is 0 will give my solution minus 1/3 pi, and k is 1 will give 1/3 plus 2. So it's minus 1/3 plus 6 over 3. That's, how was I? I get minus 1/3 plus 2 times pi is is 5 over 3 pi, so that's still within the interval, but adding another 2 pi to it will be outside of the interval. So now we go to k is -1, then we're also still inside, so we get minus 1/3 minus 2 pi, and then this is -6 over 3. Okay, -7. Oh wait, no. So I get -7 over 3 pi, but that's already outside the interval. So this is actually not a solution. So cross this out. So two solutions here, and let's see. There will be many more solutions here. Might be out of space. So let me continue here. Okay, k is 0. We get 2 over 9 pi. K is 1. We get 2 over 9 plus 2/3 pi. I put it under the same denominator, 3, 6. I get 6 over 9. It's 8 over 9 pi. Still within the interval. K is 2 over 9 plus 4 over 3 pi. So again, put it under the same denominator, times 3, 12, 14 over 9 pi. It's still in the interval. Now the interval is up till 2 pi. Actually, another way is just keep on adding 2/3 pi to each. If I add another 2 pi to this, well, okay, doesn't matter. So let me still keep the original place. 2 over 9, and then k is equal to 3. K is equal to 3. Then it's just adding 2 pi and adding 2 times pi here. So yeah, that will be something larger than 2 pi. Don't even need to calculate it. So we rule out this. And now we go to -1 for k. Yeah, it's meticulous work, not difficult, but easy to make mistakes. So minus 2 over 3 pi. So I get 2 and then minus 6 is minus 4 over 9 pi. That's in the interval. Is negative 2 over 9 minus 4 over 3 minus 12. This is minus 10 over 9 pi. Okay, it's negative 3. I get 2 over 9 minus 2 pi. So that's also still just within the interval. At 18 over 9 is minus 16 for 9 pi. Okay, I think basically that's it. Let's actually check if this is correct. So minus, where are the solutions? Minus 1/3 pi. 5, this is 5 over 3 pi. I think it's fine to keep it written as this. I cannot imagine they will subtract points for that. Then 2 over 9 pi, I had that 8 over 9. 1. So this one is again, this is same as 14 over 9. Minus 4, minus 10 over 9. Oh, minus 17 over 9. Ah. Yeah, so that is correct. Again, easy to make mistakes, so best to go slow and steady in these. Question 3c. We have a tangent line M through of f at point A, a tangent line N of f at point B, and a point D that's the intersection of M and N, and a point E that's the intersection of N and the x-axis. So let's try to draw that. I would strongly advise to do that, just to get a good picture. So we have a line N. So this is the tangent N, and then there is a tangent at B, goes about like this. This is M, and this is a point D. Now we have also a point E, and then they say this is an equilateral triangle. That means all these angles here, let's call it A, E, and D. All these angles A, D, and E are 60 degrees. So we have to prove that A equals E d equals 60 degrees. So how can we show that? Well, the angle A should be pretty easy to find from the slope. And angle D can be found from the slope from N and M. It's angle D is just the angle between these two lines. And angle E is probably a little bit more complicated because you need to find point E first. But we need to have it from 2 points, to prove it for 2 angles is good enough, since we know that the sum of the angles has to be equal to 180. So let's calculate the A and D. Alright, so the slope at point A, I need to find the derivative of the function at minus 2 over 3 pi. So that will be minus 2 times the sine of minus 2/3 over pi plus 2 times the sine of 2 times minus 2 over 3 pi plus 1/3 pi. Okay, well, for this you just need to be able to do it. Maybe use a unit circle, even your calculator. So if I just have on some corner of a paper, just try to work it out. So you get like a circle where you're somewhere here. So this is minus, and you have to have these numbers in your head. Again, if not, just put it in your calculator. But this is minus 1/2 square root of 3. Oh, wait, there is a 2 here. Minus 2 times 1/2 square root of 3 plus this minus 4 over 3 pi plus 1/3 is minus pi. The sine of minus pi is 0. So this is just wait, this is negative 1/2 of square root of 3. So this is I know, since we want to prove it's 60, I know it has to be the square root of 3, because the tangent of 60 degrees is square root of 3. So I found that the angle A is 60 degrees. And then this angle here, the angle D, well, let's find the slope of line M. The slope of M, and that's the slope in point B. X equals 1 pi over 3, so that's an f prime at pi over 3 minus 2 times the sine of pi over 3 plus 2 times the sine of 2 times pi over 3 1 over 3 pi. So now where are we in the units circle? Well, 1/3. So you get actually the opposite sign. You get minus, well, let me write it out, minus 2 times 1/2 square root of 3. And this is still 2/3. This is pi, so this sine of pi is 0. So get negative. And the tangent of minus 60 is, so this is the tangent of negative 60 degrees. And that makes sense. The line M, what they call like a directional angle of line M is negative. It's negative 60. That's the angle with, say, the positive x direction, which is related to the slope. Again, that's written in the materials. So, so what's the angle then between the lines L and M? Well, you need to subtract these angles. So it's 120, but that's but then you need to take the acute version of that. Basically, that is the angle here. So if you have two lines crossing, then this is the the angle of, say, line 1, line 2. This is this angle is alpha 1 minus alpha 2. But if this is acute or obtuse, when this angle is larger than 90, you need to take the complement. So you need to take 180 degrees minus 120, which is 60 degrees. So the angle D is 60 degrees. And with that, you have proven that this angle has to be equilateral. Question 3D. The curve of f and x enclose two types of regions, the one below and the ones above. I use commutation to investigate whether these types of regions are equal in area. Well, we've seen that this is a periodic function, and the periods actually can be found from the periods of the cosine, the sine. It's actually the least common multiple, these periods. And the period is actually 2 pi. So we just need to evaluate the integral of one such a period. Then if that's from that we can tell whether or not the regions are equal in area. So let's calculate the integral from a to c. Again, that's one period, 2 pi. Minus 2/3 pi to 4 over 3 pi of that function, and we need to find the primitive. The primitive is just a sine of x, and from the second we get a cosine with a negative sign, and because of the chain rule you would pick up another factor 2 which you want to compensate for. So you get a a negative 1/2 cosine of 2x minus 1/6 pi, and between 4/3 pi and minus 2/3. And just always double check. If I take the derivative here, I get the sine of the inner function times, no, I get I get the negative sign of the inner function, and then times 2x. So I will get the plus, get this function back here. Okay. Do I get 2 times the sine of 4/3 pi minus 1/2 cosine of 8/3 pi minus 1/6 pi minus 2 sine 4/3 pi minus 1/2 cosine of negative 4/3 minus 1/6 pi. Do this all very careful. It's very easy to make mistakes. So sine of 4/3 pi. 4/3 pi means this is 1 and 1/3 pi, so I rotate by pi and then another 1/3 more, so I end up here. I think actually we saw this before. This is 2 sine 2 times minus 1/2 square root of 3. And this, well, let me just write it out. That's probably always a good idea, that when you get graded they see that you did the right thing, but at least if you made a mistake they can follow what you did. So you get a cosine of, put this under common denominator, get 16 minus 1, it's 15/6 pi, and then here, how come I get the, did I make a mistake here? 4/3 pi, how come that's, well, that's should be a negative. This would be negative 2/3 pi. So we rotate in the negative direction by 2/3 pi. Well, actually we end up here. Get 2 times minus 1/2 square root of 3 and then get rid of the parentheses here, so minus this, and then these together give a plus sign. It's 1/2 the cosine of, this case, same denominator, minus 8, so minus 9/6 pi. So let's put this here. Here you get a negative square root of 3, and here positive. So these two drop. And what's the cosine of 15/6 pi? Well, 15/6 is equal to 2.5. Well, 2.5 make one rotation and then half rotation, or half pi rotation, I should say. You get actually 0. So this equals 0, or minus 1/2 times 0, and minus 9/6 pi is minus, so simplify, minus 1/3, minus 3/2 pi. Well, what's that? That's minus pi, and then another minus 1/2 pi. So minus pi minus 1/2 pi. So that one is also 0. So this whole thing is 0, which means that the regions are equal. So from this follows the regions are equal. Question 4. Rational function and two circles. Okay. We have the function, and they state that it has two asymptotes. Use an exact computation to find an equation for each of these asymptotes. Well, one thing we would want to look at is what happens when x goes to positive or negative infinity. And the way to do this is to divide by the highest degree in either the denominator or numerator, and then check its behavior. So let's do that. So we check the limit x goes to, say, plus or minus infinity of that function, and rewrite it as the limit of 8 divided by x minus 12 divided by x squared. It's perfectly fine to do this division because x is non-zero. 6 minus 17 divided by x, and then the 12 divided by x squared. And then these two have known limits. They all go to 0. So you get the limit, doesn't matter, x goes to plus or minus infinity. you get 0 divided by 6, and then yeah, basically minus 0 plus 0. Looks a little weird, but you get the idea. This is 0. Doesn't matter, x goes to plus or negative infinity, so that means the x-axis is the asymptote. Y equals to 0 is the asymptote. Y equals to 0 is one asymptote. So that's the behavior for plus minus infinity. And then what other thing that can happen with these functions is that the denominator can reach 0, in which case this can blow up. So let's investigate that. We take the limit. Let's see if we can rewrite the function. Let's see if we can if this gets 0, and see if we can investigate it by factorization. So we could write this as, say, 6x and then we just look at the factors of 12. So 1, 12, 3, 4, oh, also 2, 6. Yeah, these are these. So you can have like a minus 3 minus 4 plus 3 plus 4. 1 and 12. And then we just need to see if this adds up to minus 17 in some way. So you need to have some negative. Say minus 3 minus 4. No. Yeah, they need to have the both signs, or both negative or both positive. Minus 2. No, that doesn't work. Let's also check the other like combination that leads to 6x, which would be 3 and 2x. Then again try minus 1 minus 12, doesn't add up to minus 17. Minus 3 minus 4 is minus 6 minus 12, no. Minus 4 minus 3. Yeah, that leads to something. This is minus 9 minus minus 17, so you can factorize this. It's definitely to be expected in this kind of exercise. If you cannot find this, you can just use this square root equation to find the roots of this. So this can become 0 when x is 3 over 4 or x is 3 over 2. As a matter of fact, let's rewrite the function. So fx, I take out there's a common factor here, namely 4. So write it as 4 times 2x minus 3, then divided by 3x minus 4 times 2x minus 3. And you actually see this common factor, and when x is not equal to 0, this is just equal to 4 3x minus 4 when x is not equal to 3 over 2. And when x is equal to 3 over 2, this function is not defined. So now we've written it in this form, we immediately see there is actually a vertical asymptote when x goes to 4 over 3. Just take the limit and then you find 4, you get 4 over 0, and that's that goes to infinity. And what happens when x reaches 3 over 2? Well, it's not defined at 3 over 2. But the limit, actually the limit is finite, has a finite limit. The limit is actually given by 4 divided by 3 times 3 over 2 minus 4. It's some finite number, so it's definitely not an asymptote. So the limits are either from above or from below. It is finite. In any case, yeah, you probably don't need to investigate this because you already found 2 asymptotes and it was given that it had 2 asymptotes. So probably just write below here that there. So yeah, an equation y equals to 0, and the equation for number 2 is x, the line x equal to 4 over 3. Question 4b. We have a circle C1 that touches graph f at the intersection point of this graph and the y-axis. And the center of this circle lies on the line with this parametric representation. This is basically a vector equation, a vector representation of the line with a position point and a direction vector, a scalar constant times a direction vector. So what does that mean? Even though I don't know exactly how the curve looks like, but the principle is that, say I have a curve and touching means that the tangent in this tension point is perpendicular to the radius, the point from the center of the circle through the tension point. So then it becomes clear that we need to find the slope of the function f here. So what is its slope? Since this line has to be perpendicular to the tangent. So let's so then we know, if we also know the coordinates of this point, which is given, then we can have set up an expression of we can find this line, and then we also know that the center of the circle is on this line. So this line goes angle 45 degrees up. So let's say, let's try to roughly draw it here. it should go, it's something like this, and then we just need to find the intersection of this line of the line with this representation with the line that's perpendicular to the tension through this tension point. So let's find the tangent point or point of contact. Well, that's given here, the intersection of this graph and the y-axis. So that's just the coordinates of that are 0 and then f of 0, which is a 0. And what is f of 0? Minus 12 divided by 12 is minus 1. And what's the slope? The slope, well, we need to find the derivative of this function at 0. So we use the quotient rule for differentiation. We get the denominator, and then we get the derivative of the numerator, and we get 12x minus 17, I assume. Since this comes so frequently, you guys know this. This is the derivative of the denominator and times the numerator. And well, I'm not going to repeat that. So substitute 0, we get 8. No, we get 12 times 8. And here we get 17 times 12. Just need to get a sign, right? Minus 17 times minus 12, but there's also another minus sign here, so it's a net minus sign. And then divided by simply 12. So I get, is this all correct? 12 times 8. Yeah. Or divided by 12 squared. So what is this? I can actually drop 1/12 here. This becomes 1. That's 18 minus 17 is minus 9 divided by 12. So not exactly this situation here. It's a negative slope, but that's okay. It's minus, simplify this. Greatest common factor is 3, minus 3 over 4. And that means that the slope of this radius I was talking about has to be negative 1 over this. Right? The two lines are perpendicular if product of the slopes is equal to minus 1. So the let's call this line L. So it means the slope of L has to be 4/3. And this line has to go through the tangent point. So let's assume it has this. Let's use the slope-intercept form. Y equals mx plus b. We know m is 4/3, and we know that this point is on the line, so -1 equals b. So we found our line. Y equals 4/3 x -1. And now let's intersect this with this line, with this parametric representation. X, y equals 1, 2 plus lambda 1, 1. Okay, so how do we do that? So let's substitute this in this equation. Well, no, let's actually write this in a similar representation, and then this you get two equations of two unknowns. So this means x is 1 plus lambda, and y is 2 plus lambda. Eliminate lambda, or no, substitute what you get for lambda from here. So x minus 1. Get y is x minus 1 plus 2. So y equals x plus 1. You can see the slope is 1, which you can have already figured out from this direction factor. This is 1, 1, means say 1 to the right, 1 up, so a slope of 1. And 0.12 is on the line, so which you can also easily see here. So I have this line, I have this line. We can easily solve x of the intersection then by, we have to set 4/3 x minus 1 is x plus 1. So subtract x from both sides, so get 1/3 x is 2, which means that x is equal to 6. And then substitute it in the line, and you get y is equal to 7. So we found our center, the circle. And what then for the radius? Well, the radius is the distance from this tangent point to the center. This is the, which was given here, so it's the 6 minus 0 squared plus 7 minus -1 squared, and then the whole square root, don't forget that. A little bit out of space here, and this doesn't make any sense, sorry. Seven minus -1, and that whole thing squared. So that's 36, and 8 squared, which is 64, and then the square root is 100. So okay, I might just have space here. Then the circle is given by x minus, what was it again? Six squared plus y minus 7 squared is equal to oops, careful with this, is equal to 10 squared, that's of course 100. So this is our final answer. The last question, 4c. We have this circle, A and B are 2 points on it. The tangent line to the circle and these points intersect at an angle 30 degrees. Compute algebraically the distance between points A and B in 2 digits behind the decimal point. So it's something like this. We have a circle and then a tangent line from one side and one from the other side with a angle 30. And this is happening in the tangent point here is A. The tangent point is B here. Let's say the center of the circle is here. We know this has to be R, the radius. We know this radius, but see they're asking this length A and B. Well, we know that this A, the lengths from A to this intersection, B to intersection are the same. So it's an isosceles triangle. That means that these angles here let's mark them here. These angles here are the same. Let's call these alpha, and that means, given that the sum of the angles in this triangle have to be 180, we can find out what these angles are. And if we know that, we can actually find the angle opposite of AB, of this small triangle here, from the center of the circle. If we know this angle, and since we know the radii here, we can use the cosine rule to figure out what the length of AB is. So the strategy is to find this angle here. And you can also use that the sum of these four angles is 360. I guess let's do this way. That the 2 alpha plus 30 has to be 180. So alpha is 75. Then we can find out what these small angles are, because these are just 75, well, 90 degrees minus 75, because these are perpendicular to the tangent. So these are 15 degrees. And now we can use that the sum of the angles in the triangle is 180 to figure out this angle here. Well, that then is 180 minus 2 times 15 is 150. So now we can use the cosine rule. Gives you something of the opposite side of an angle in terms of the angle and the length of the other sides. And it is listed as something you need to know in the materials. So let's call this angle alpha. Oh, I already used alpha. Beta. And state that AB with the cosine rule is the square root of, well, r squared, that's the other side, plus the third side, and minus 2 times r, the two sides, times the cosine of beta, which is 150. And then the square root. Okay, what's r? Well, r we find by writing this, rewriting this in the circle form and by splitting the squares. So what we do is we say that x squared minus 8x plus y squared minus 6y0, we can rewrite it as splitting the squares by saying x plus something, so that you get the x term, this linear term back, so it has to be a minus 4 squared. So if you do this, you get your x squared, you get minus 8x, but you get another term, minus 4 squared, which I need to subtract. So the x squared and minus 8x I can write as this combination. And do the same for y squared, and I get y, well, minus, and have this thing, a minus 3 squared, and then I get a 9 that was not there, so a minus 9 equals 0. Then I bring these two to the right, and that looks actually good. I get equals 25. So R is 5. So now I substitute this in 1, and I get the length of the segment AB is the square root of, this is 2 times r squared. R squared is 25. So 50 minus, again, 2r squared, or minus 50 cosine of 150. And then the whole square root of that. Let's see. 150, put my calculator on degrees. Do cosine. It's negative this. I do times 50. But I need to subtract it. So I give it a minus sign and then just add 50 to it. It's 93. Take the square root. Is 9 point in 2 digits. Oops. So 9.66. Okay, so let's that. Yeah, that's correct. Yeah, this is a little bit more tricky. Basically, what did we apply here? Some rules about triangles, mainly, and the other knowledge here necessary is that the tensions are perpendicular, say, on the radii of the circle. Okay, that's it.